I'm sure we'll have lots to discuss when we get it all together. Well, let me give you my interpretation now, and then we'll have Mark's interpretation, and then we'll have a general discussion. Okay, so I call it revitalizing the tradition, which I'll explain as we go. The claim is that there's a current transition to reflexive knowledge, that many people have contributed to this. The ones that I've been following and am familiar with are Heinz von Forster, Vladimir Lefebvre, George Soros, Karl Mueller, etc. So there's Heinz, Soros, Mueller, Lefebvre, Lou Kauffman, whom Karl referred to, Klaus Krippendorff, so forth. So the basic idea, from my point of view, is that science can be expanded by adding the observer to what is observed and considering the coevolution of theories and societies. And I picked up that notion from Heinz when I was a student. This would shift our thinking from viewing science as creating descriptions of systems to viewing science as an active part of social systems. And that's an idea that will underlie what I'm saying here, is the importance of purpose. That by an attempt to eliminate bias, I think we also eliminated purpose. And to know the purpose of the person doing the work is extremely informative. Okay, Popper talked about worlds 1, 2, and 3. The numbers are a little misleading. For Popper, world 1 was the world two was the observer, or the impressions in the mind of the observer, world 3 was descriptions. And that leads to, I think, 3 epistemologies. The first, the creating descriptions of the world, is sort of the classical philosophy of science, or the most well-known philosophy of science, where the idea was to exclude the observer. But if you decide you're interested in cognition, then that leads to a second epistemology where you're primarily concerned with the observer and how the observer creates descriptions, and you don't really need to pay much attention to the world, because after all, the world exists in the mind of the observer. So you emphasize 2, de-emphasize a third. And then in a practical domain like management, people want to act in the world. They're not much interested in theories and philosophies. So you emphasize the observer's interaction with the world, and you don't pay much attention to descriptions. So to me, there are sort of 3 identifiable epistemologies, but I think that if you combine them, you get a richer interpretation. Okay, now, one of the things I've learned from talking to Mark Letourneau over the years is that philosophers and scientists have different views. And philosophers have a rich and multifaceted and deep understanding of the philosophical literature, and scientists, particularly in the social sciences, just try to imitate physics as best they can, meaning they want to create objective descriptions, and they don't really have a very deep understanding of philosophy of science and so forth. So the way we think about social science or social systems is also different depending on whether you're a citizen or a journalist, or if you're a scientist. It's easy to accept the fact that we create theories because we hope that people will accept them, act upon them, and society will operate better. But when scientists conduct research, they usually assume that the theory does not affect what is studied, because in physics it doesn't, generally. And we act this way because we're trying to create objective descriptions. Okay, so that's a bit of background. Now, there are models used in doing science, and you can identify different structures of these models. For example, linear causality. How does variable A affect variable B, maybe with an intervening variable C? This is the workhorse in the scientific community. Many doctoral dissertations take this form of trying to find a relationship between 2 variables, and one engages in Procrustean activities trying to measure some sort of psychological variable like trust or abuse or something like this. There's a lot of this literature in management. Then there's circular causality, which is essential in any regulatory process. You can make nice causal influence diagrams, you can create system dynamics models, but you have relationships between variables of a circular form that can be either positive or negative. Then there's the concept of self-organization. In the concept of self-organization, you have a finite system, which is dynamic, meaning energy flows through it. But for a period of observation, the interaction rules don't change. And so you have a very large number of elements that tend to go toward their equilibrial states. Adam Smith used this model when he talked about competition among firms or competition among countries. Charles Darwin used this model when he talked about competition among species. And lately, it's the idea underlying complex adaptive systems and Wolfram's work and so forth, where you enter a set of variables or entities, define the interaction rules among them, and then let it run to its equilibrial states. You can then step back, change the interaction rules, and let it go to another equilibrial state. Like if you set up an incentive system in management, you're changing the interaction rules. You think people will pursue those rewards, and you'll get more sales. You change the laws to outlaw certain types of pollution. You get less pollution. These are all instances of the concept of a self-organizing system. There's a fourth model, and that's reflexivity. There are variations of it on Forster, Soros, Lefevre. I have found for my work that the Soros's model is particularly interesting because he deals with social systems and management and so forth. And in that case, what you're doing is the actor observes, decides, acts, steps back, observes, decides, acts, etc. Practical people have no trouble with this concept. Academics get very puzzled about it. But managers, government officials, they say, yeah, that's the way we work. So there's a difference there. So in this case, you have a circular process. The observer is included, and it operates on two levels, both observation and participation. Now, here's some little diagrams. So one way of thinking about science is that you're trying to create accurate descriptions of what's in the outside world. Or you can include the observer and say that you're interested in the interaction of the observer with the outside world. But in a social system, you have a large number of people, all of whom are thinking about other people, trying to get along with other people, etc. Okay, there's another way you can think about social systems. That's in terms of the basic element of the description of the system. And there are at least four: variables, ideas, groups, and events. And these are popular in various fields, like variables works in physics and economics because you can have measurable variables. And that's the preferred way of doing things because it's quantitative. You can come up with equations, collect data, and all sorts of things. But in some areas like anthropology and psychology, it's hard to come up with variables. So you deal in terms of ideas. Or in the case of sociology and political science, you're interested in groups or coalitions, which are many times identified by the ideas that they operate on, and they act in the world and they produce events which are recorded in history or law. Now, the problem with all of this is that if you have a discipline-oriented university, each discipline is focusing on a piece of the problem. They're focusing on a part of the social system. They're using a particular lens to look at the social system, as opposed to taking a holistic view. And you can indicate that variables and ideas exist at the level of ideas, and groups and events exist more at the operational level. Okay, and that's a sort of special case of an epigenetic theory that Karl has talked about in other places. Okay, so the basic idea is here to try to come up with a more holistic vision of the social system. And here's, I just want to emphasize the importance of purpose. As I've read the philosophy of science literature, it seems to me that the emphasis is on trying to come up with descriptions of the world. And we want descriptions that are universal and general knowledge. If you take a cybernetics approach, where cybernetics is a science of purposeful behavior, it's a science of purposeful systems, then you tend to view science as an element of a purposeful activity. That is, you create science in order to achieve your purposes. You create general knowledge because you want to communicate with other people and pass on what you've learned. But those are all purposeful activities. So I would see the purposeful activity of individuals and societies as the larger context for the creation of universal general knowledge. So that the methods that we create for developing universal general knowledge should not prevent us from creating knowledge of what is useful for survival, because it seems to me like that's the larger context. Now, as I understand the philosophy of science, and I say these things to prod Mark to correct me in my errors, that philosophers have primarily used the method of rational criticism. But now that we have so much knowledge from many disciplines, anthropology, psychology, sociology, and so forth, why not use that knowledge in addition to rational criticism to reflect upon the scientific enterprise? So I think we're in a position to do that, to use additional methods and to use the findings from other disciplines.
Can you go back?
You'll have your chance, Mark. Okay, so it seems to me like there are a few principles out there in the philosophical literature, and I just want to call your attention to a few. Demarcation was the idea, Popper's notion, of how do you distinguish science from non-science. And the idea is that scientific statements should be falsifiable. Then there's the notion of induction and the fact that you cannot create universal general knowledge through induction, because the next statement that you see may run counter toward your general principle. But you can disprove a proposition. You cannot prove a proposition, but you can disprove a proposition. Now, Soros, in a recent article, has postulated the notion of reflexivity, in which he says that if you have a system in which there are thinking participants, that is fundamentally different from a system composed of inanimate objects. So I'll show you his statement of it in a moment. And then there's the correspondence principle, which I'll explain. Okay, so demarcation. So Soros on reflexivity. Systems composed of thinking participants are different from systems with non-thinking participants. The presence or absence of reflexivity serves as a criterion of demarcation between social and natural phenomena. Now, the reason that that's tricky is because you have observers involved in physics and chemistry too, because they're the scientists. But it's even more complicated when you're dealing with social systems in which the objects being investigated are also thinking participants. Now, the correspondence principle, some of you heard me talk about the correspondence principle, so I'll go over this very quickly. It's a way of charting the development of science. And it was developed by Niels Bohr when they were developing the quantum theory. It said that any new theory should reduce to the old theory for those cases in which the old theory is known to hold. The idea is you need to add a new dimension. Okay, so, for example, you have the old theory or the old philosophy. I think you can apply the principle to the philosophy of science in addition to a particular scientific field. And you expand the domain of what can be investigated by adding the dimension. If you don't want to pay attention to that new dimension, you can practice science the way it was done before. But that's in a way of expanding the domain. Okay, so just to give you a few examples, in relativity theory, in Newtonian mechanics, mass, length, and time were fixed. If you go to relativity theory, look at the speed of light, then you come to the conclusion they're variable in some extreme cases. Or in the case of the gas laws, pressure, volume, and temperature were used to describe the behavior of gases, The diameters of the molecules were neglected because they were very small. But as we learned to compress gases, the diameters became significant. So you had to add in the diameters of the molecules in order to get suitable laws. And so then second order science, as I'm thinking about it, would be to add the amount of attention paid to the observer and the effect of the theory on the system described. So the intent is to expand our conception of science so that we can see more, we can investigate more than we could before we added in these two dimensions.
Could you say that again, please?
By adding these two dimensions of the observer and the effective theories.
No. Your definition of second order science. You said that the second order of science was...
It allows us to investigate phenomena that we could not otherwise investigate.
She's asking what it is, not what it allows us to do.
Oh, well, there are many, many possibilities.
You just made a statement, though, and I wanted to make sure I caught it.
Well...
Because it was surprising, which is not what I was expecting.
Oh.
Never mind, go ahead.
Well, second order science would include attention to the observer and attention to the effects of ideas on the phenomenon being investigated. In my definition, Karl would say it somewhat differently. Okay, now, let me cite a favorite philosopher in the room, Karl Popper. He talked about a second order tradition in conjectures and refutations. So let me just go over that. He said that what we call science is differentiated from older myths, like religious myths, not by being something distinct from a myth, but by being accompanied by a second-order tradition, that of critically discussing the myth. Before, there was only the first-order tradition. You pass it on. Now, there's still the story to be handed on, but with it goes an accompanying text of second-order character. This second-order tradition was critical or argumentative attitude is the fundamentally important thing about the scientific tradition. Scientific myths are different from religious myths because if one adopts a critical attitude, then one's myths do become different. They change. They change in the direction of giving a better and better account of the world, of the things that we can observe. And they also challenge us to observe things which we would never have observed without these theories or myths. In other words, if we're making an assumption and we're not aware of the assumption, we have constrained what we can perceive. If we become aware of the assumptions that we are making and relax that assumption, like don't exclude the observer but include the observer, you can see more. And that's what I think we're doing, is revitalizing the tradition of science reflecting on itself. Any questions, or shall we turn it over to Mark?
I just got kind of a point, counterpoint.
Yep.
Well, I don't know. Thank you for inviting me, and thank you for coming to here.
Wait. Stick that in a pocket.
And so if women are doing this and they have no pockets, what happens to the transfer of the microphone?
Oh, there's a clip. You can clip it on.
What about the thingy that's in his pocket? What do you do with that? Oh, that's clip also. So,
Sometimes they put a lanyard on it. You can hang it.
It's not sexually biased. It's yeah, let me just begin with just a couple of observations related to Karl's talk, because I didn't really know that part of the impetus for talking about second order science was that von Forster introduced the term but didn't say much about it. And it reminded me, as some of the symbolism actually that you were using in your talk. There was, and I'm not sure that this was an idea that he was aware of or that might have influenced him, but there was, along about that time, a very well-developed notion of second-order logic. And